Yes, so I welcome you all on this wonderful platform that is BYJU'S Exam Prep. And guys, today we are here in this episode of Concept Capsule, where we are dealing with some complicated topics which are very important for the exam point of view as well as interview point of view, and students are facing very difficulty in those topics. So those topics, to clear your doubts, to make it crystal clear in front of you, we are coming in Concept Capsules episode. In the previous two episodes, we have seen about centripetal centrifugal forces, thermodynamic mechanical cycles. And guys, in this episode, we are going to talk about the mystery of the transmission angle. So as the name suggests, I feel everybody would be understanding that we are talking about theory of machines, first chapter, simple mechanism, simple 4-bar mechanism, where concept of transmission angle comes into picture. So we are going to see what is transmission angle, what are the ranges, means minimum and maximum values of it, and why the range of this angle decides the quality of a simple 4-bar mechanism. And we will see the minimum maximum value in both crank rocker and rocker configuration. Okay, so let us start the session, guys. So guys, first of all, this is some introduction about me. Those who are looking or having this session for the first time from my side, for them this is the introduction of mine. I am having around 10+ years of experience, written many research and review papers, and my areas of expertise are strength of material, theory of machines, vibration, engineering mechanics, production, industrial and machine design. So guys, let us move further. So my dear, those students who are looking for a single digit rank and they are facing problem in the revision technique, that how you shall revise the things, for them this session is going to be there. I feel tomorrow 17th May, Tuesday at 10 PM on the same channel. So you all are invited for the same, and just come and clear your doubt and try to understand what should be your revision strategy for a single digit rank or for whatever you want to achieve from the GATE exam. So my dear, first of all, we are going to start the session now. First of all, I will be telling you actually what is transmission angle. So you know, this is a simple 4-bar mechanism. In this is link number 1, which is a fixed link. This is link number 2, which is input link. Link number 3, which is coupler, and link number 4, which is output link. And my dear, you know, when you will be giving rotation to input link, output link is going to rotate like this. And at the same time, my dear, when we are talking about this simple 4-bar mechanism, this angle, the angle between fixed link and link number 2, this is denoted by theta, and this is said to be crank angle. This is said to be crank angle. Okay. And my dear, the angle between crank and coupler, this is denoted by beta. And the angle between coupler and output link is denoted by mu. And this mu is given the name of transmission angle. So my dear, this session is related to the transmission angle. And now we get to know transmission angle is nothing but the angle between coupler and output link. So my dear, in general, whenever we are talking about the transmission angle, the ranges of that, it means we are talking about the configuration where output link is not making complete 360-degree rotation. Means we will be talking about two mechanisms. One is crank rocker. One is crank rocker configuration, and second is double rocker configuration. And my dear, I would also like to tell you one more thing. When we are talking about these two configurations, crank rocker and double rocker, you must be knowing by Gradeup law we decide which type of configuration is going to be there. Like you know, when Gradeup law S plus L less than equals to P plus Q is satisfied, then shortest link fix guarantees about double crank. Shortest link at input or output guarantees about crank rocker. And if shortest is just in front of the fixed link, means it become coupler, you get double rocker mechanism. So my dear, this we have already seen in the Gradeup law. So now we will be talking about this transmission angle. And my dear, this transmission angle, when we are talking about the range of transmission angle, when I am talking about range, it means I want to know the minimum and maximum value of transmission angle. Because The transmission angle value is telling us about the quality of simple 4-bar mechanism. How it is quality, I will be telling you after some time in this session only. So if you see, this is a simple 4-bar mechanism in front of you. Okay, for simplicity, this OA is crank, the side is denoted as A, this is D, this is C, and this is B. I am taking this as K. I am taking this AO4 as K. So my dear, now we are going to talk about the transmission angle range mu, what will be minimum and maximum value of mu. For that, let us solve two triangles which are present here. So my dear, let us assume this angle to be theta only, because there is only one angle. So why assume theta 2? It is theta, it is mu. So my dear, I am going to consider a triangle first of all, the triangle O2AO4. The triangle O2AO4. If we are going to take this triangle, my dear, everybody would be aware of cosine rule. You have studied in trigonometry class 11th. So you must be aware of that. We can write A square plus D square minus 2AD. The angle between these two is theta. Cos theta is equals to, the side in front of this angle is K. It is K square. This is equation 1. We have written it from triangle O2AO4. Now let us go to another triangle, triangle ABO4. Once again apply the similar thing, this time between B and C. B square plus C square minus 2BC cos mu is equals to K square. This is equation number 2. If you see both the equations, my dear, right hand side of both the equations are same. So left hand side must also be same for both. So I can write A square plus D square minus 2AD cos theta is equals to B square plus C square minus 2BC cos mu. My dear, you want to find out the minimum and maximum value of transmission angle. And my dear, first of all, whatever the things I am going to do is valid for crank rocker mechanism, because for double crank we need not to talk about that, because it is both rotations are there. So when crank rocker is there, then only transmission angles range matters. Okay, so my dear, first of all we are talking about crank rocker configuration. And my dear, you can see in this equation, if we want the maximum and minimum of mu, you know, if we want to maximize or minimize y, we are going to put dy by dx to be equals to 0. Here we want to maximize or minimize mu, so you will be going for d mu by d theta is equals to 0. For that we need to differentiate the equation. Let us differentiate the equation. So my dear, I am writing once again the equation in front of you. We were having A square plus D square minus 2AD cos theta is equals to B square plus C square minus 2BC cos mu. Let us differentiate it. You know, A square is a constant, D square is a constant, differentiation is 0. Minus 2AD cos theta will become minus sin theta. Is it correct or not? Cos theta will become minus sin theta. So minus sin theta is equals to, you know, it is B square and C square are constant, minus 2BC will be. This is cos mu ka minus sin mu. Then you know, for mu it will be d mu by d theta, because theta ka theta ke respect mein is going to be 1, mu ka theta ke respect mein is going to be d mu by d theta. So you can write d mu by d theta as, you can write d mu by d theta as, you know, minus minus will get cancelled out. This minus minus will also get cancelled out. So you will be having this as 2 will also be getting cancelled out. AD sin theta divided by sin mu BC. You will be putting it to be 0 because you want to maximize or minimize mu. When you will be doing that, you know that AD and BC are the link length, cannot be 0, and sin mu, these term will be going and multiplied to 0 and become 0. So it is saying us that sin theta should be 0. You know, sin theta is 0 when theta is 0, pi, 2 pi, and so on. So these are the values where we can have sin theta to be 0. or d mu by d theta to be 0. So my dear, if we will try to apply this condition in the simple 4-bar mechanism, what we are going to get? Let us see what we are going to get. So my dear, if you see this, one condition is that where we are going to make this theta to be 180 degree. You know, theta is the angle between this. This is the condition when crank will be like this, okay, and that angle will be 180 degree. And my dear, second condition is when crank is at this position, like you can see. So at this time, my dear, when you are looking at the crank like this is making theta to be 0. And my dear, because you know crank, whenever this crank was moving like this was making the angle theta like this. So at this position, the crank is making theta 0, and at this position, the crank is making an angle of 180 degree. And if you see carefully, my dear, when theta is becoming 0 degree, at that time you are going to have this value of mu, and when you are getting theta 180 degree, you are getting this value for mu. And my dear, obviously by looking on the first time, you can identify that this value is smaller, this value is bigger. So we will be saying this is the maximum value of transmission angle, this is the minimum value of transmission angle. And my dear, when we are talking about, I can show you the diagram with very much simplicity. If this is the fixed link, when we are having crank in this position, then my dear, you will be having mu to be maximum. And this is the condition when theta is 180 degree. So for theta 180 degree, you will be getting mu maximum. And my dear, when we will be having the crank to be making an angle of 0 degree, when the crank will be making an angle of 0 degree, crank will be coming like this. It will be coming like this. So this angle is mu minimum. This is the condition when theta is 0 degree. Now you know 180 means pi. So when theta is 0, this is the condition, theta is pi, this is the condition. When theta will be 2 pi, this will be the condition. When theta will be 3 pi, this will be the condition. So for all other value, the condition is going to remain same. So my dear, we got to know when we will be getting mu to be minimum, when we will be getting mu to be maximum. So my dear, now whatever you are getting the mu minimum value and mu maximum value, this is said to be the range of transmission angle. So two purposes are already resolved. First purpose was what is transmission angle. Second purpose was what are the minimum and maximum values. Yes, we have seen only for crank rocker configuration now. So my dear, why we are so much worried about this range? My dear, in simple 4-bar mechanism, like you have seen in the first slide when I defined transmission angle, you can see whenever you are going to give rotation to the crank, the output link will be rotated, and that will be rotated because coupler will be supplying some force to that. Coupler will be providing some force to that. So my dear, if you just try to feel one thing, that if this is my output link like this, and my dear, let us say this mu is coming out to be around 90 degree. And if that is the case, my dear, the force is going to be transferred like this. This is the output force, which will try to rotate the output link. And you can see, my dear, the torque output I will be writing as force output into perpendicular distance, which is the distance of this from this point. And this, let us say, is, this distance is, let us say, S. So F output into S. This is going to be torque output. So if this angle is 90 degree, you are going to get this. If this angle is not 90 degree, less than that, you can imagine one thing, that if we are going to have this link like this or this link like this, then my dear, if you will be finding out the distance, that distance will always be lesser than S. And if that distance is going to be lesser than S, it simply means that the torque output is going to be affected. So my dear, torque output will be reducing because it is the product of F output into S. So my dear, if angle is lesser than or more than 90 degree, in both the conditions, we will be getting lesser torque. And my dear, it have been observed when this angle is going far away from 90, like near to 45 degree or lesser than that, then my dear, this output torque is becoming very less. So much less that it is going to be very difficult for that torque to rotate the output link. And my dear, for such situations, my dear, we will say the quality of 4-bar mechanism is not good. So that is why we generally say a simple 4-bar mechanism to be of good quality in crank rocker configuration when transmission angle is not going far away from 90, because during motion it is going to change for sure. But if it is not changing much, it is varying between somewhere 70 to 110, it is said to be a good one. But yes, lesser than 45, we need to worry about that. Okay, that is why the range of transmission angle is said to be the quality of simple 4-bar mechanism. And my dear, now this is true whatever we have seen for crank rocker configuration. What if we have double rocker configuration? Then what would be the case? So my dear, for double rocker configuration, as you are very much aware that for double rocker configuration, first of all, let me show you the crank rocker configuration. You can see what is going on. So when theta is becoming 0, you are getting mu minimum. When theta is becoming 180 degree, you are going to get the maximum transmission angle. So that you can observe, because first of all mu will be increasing and then mu will be decreasing. Okay, so this at this position, when crank will be coming at this, you can see it is going to be minimum, the transmission angle. So this is for crank rocker. But my dear, when we are talking about double rocker mechanism, when there is no crank available, when both are rockers, then how to find out minimum and maximum mu? For that we need to take care of like this. My dear, when you have this condition, when mechanism is double rocker, means this is going to be the mechanism, there is no complete crank. In that condition, how you will find out mu minimum and mu maximum? So you can see, my dear, this is your crank, this is your coupler, this is your connecting rod. So when your coupler and connecting rod are coming in same line, this will become a triangle. This will become a triangle. है ना? And my dear, for this condition, you are going to get mu to be minimum. And the same thing when it happen in the second manner, like when you are having this as crank, this as coupler, and this as the output link, then once again it is becoming the triangle. So this is the condition when you will be getting mu maximum. So this time in these two conditions you will be getting mu minimum and mu maximum, means when this mechanism would become a triangle like this and triangle like this. So my dear, this is how we are going to see in case of double rocker configuration. How you will be knowing that it is double rocker configuration? By Gradeup law. So here we are going to solve one question also in this concept capsule, otherwise we are not solving question. But for this case I have taken a question because then only I can make you understand properly. So my dear, first of all, this is the question. This is a simple 4-bar mechanism given like this, and this link is fixed link. If you see this, my dear, you can see one thing, that shortest link is 6, longest link is this. So you know that when you are going to see S plus L, it is 6 plus 10, 16. When you are going to see P plus Q, it is 7 plus 8, 15. It means S plus L is less than P plus Q, means Gradeup law is satisfied. But now shortest link is nothing but coupler. So when shortest link is coupler and law is satisfied, we are going to get double rocker. So my dear, when we are going to get double rocker, then in that case, how to find out mu minimum and mu maximum? So my dear, you can see this is very, very small kind of link. And my dear, this is 7, this is 6, this is 10, this is 8. So my dear, for such cases, as we come to know, we cannot find out mu minimum and maximum by putting theta, 0 and pi. For that, we need to use this figure and we need to see what we can do. We need to make it a triangle actually. And my dear, if you try to make it a triangle, this is 8. Okay. Whatever we have learned till now, if we are going to go by that, how we can move in, how we can go in that way. Like, you know, when this will be like this, 7, this will be like this 6, and this is going to be, okay, let me make it properly. First of all, this is 7, this is 6. You know, when it is going to be like this link is 10. It is becoming a triangle. How to check this triangle is possible or not? You know, for a triangle, the summation of any two sides should be more than the third side. You can see this side is 7 plus 6, this is 8 and 10. So 10 plus 8, 18 is more than 7 plus 6, 13. It simply means that, my dear, that this triangle is possible. So in this case, my dear, this will be the value of mu. Okay, we don't know whether it is minimum or maximum, that we will check it. And you can apply once again the cosine rule, and you can write here with the help of the cosine rule that this is mu, and mu ke in front mein kya hai? This is 8. So you can write, my dear, 13 ka square plus 10 ka square minus 2, 13 into 10 into cos mu, and that is equals to 8 ka square. From this you will be getting the value of mu. And my dear, if you want me to tell that what would be the value of mu, I will be getting with this. So we will be getting from this mu to be 38 degree. And this is going to be mu minimum. Okay. I will be telling you why mu minimum, because second value will be coming more than this. So my dear, what is the second case? Now for the second case, what you will try to do? You will try to do, this is going to be 8. This is going to be 8. And when you will be having this to be like this, if you will try to make this like this, this is 8, this is 10, this is 6, and this is 7. If you see this is 8 plus 7, 10 plus 6. This total side is 16, and this is 8 and 7. So you can see 8 plus 7 is 15, 10 plus 6 is 16. So this triangle is not at all possible. Why? Because one side is becoming more than the sum of two sides. So in this case, the triangle possible is going to be like this. This is 8, this is 7, and this is 6 and 10. If you see this is 8 plus 7, 15. This is 10 plus 6, 16. So this triangle is possible, and this angle is going to be 180 this time. And when you are going to find out now, this is the mu, you know that. And when you will be applying the same, once again, the cosine rule. So my dear, you can write this time as 6 ka square plus 10 ka square minus 2 into 6 into 10 cos mu is equals to, this is 7 plus 8, 15 ka square. You will be getting mu as equals to 138 degree. Okay. So this is going to be the mu maximum value. So my dear, when you have double rocker mechanism, then you need to make it in this way, and you need to make actually the triangles, and you can check how this triangle is possible or not, that I have already told you. So I tried to give you the answer to all the type of questions which arises in mind by looking at the questions of transmission angle. So I feel everybody got this. This was the wonderful concept of transmission angle. So guys, hope you enjoyed this concept capsules. If you want the concept capsule on some particular topic, you can mention that in the comment section. And guys, just join my Telegram channel Mechanical by Dheeraj Sardana. If you want to have the previous year's question, handwritten notes, the PDFs of classes, and many such material which is going to help you in the preparation. So guys, like the session, share this session to your friends, and subscribe the channel. So goodbye guys for this session. Thanks for joining.